But it looks like, but still, people are still working around this CPU mechanism. Still, so what are the most like current industry standards right now to achieve this cold start latency problem? Or what are some? I mean, there's so many serverless out there as well. They're trying to optimize around it or work around it by either provisioning the GPU, or they're probably calling it just deploy loading the model and calling it a cold start. But so what are the current standards in the industry? What have you seen?
Yeah, industry actually spend much effort to optimize the GPU-based workloads cold start. This also they will happen in the academic or in the industry. For example, the most simple one is to optimize the model loading. They copy the model data from the remote store to local disk to accelerate the the model load latency, but it can still cannot make this latency to a satisfied range. And as we talked just now, and for the inference workload, there's a hard requirement for the cold start for the inference latency. For example, maybe this latency is 5 seconds, maybe it's 10 seconds. If the cold start latency cannot reach that range, that means user cannot bear that, and we have to make a service as a always on service, just pre-provision that and pre-warm the instance. Yeah, that's a major solution to mitigate this issue. And in the industry, there's some serverless inference service, and there's a major mitigation that is to handle a special configuration that is the scale down window. Scale down window means when for the standard serverless, when there's no requirement, no request, we need scale down to 0 for the instance. But in order to mitigate that, user will make a very large scale down window. That means, for example, for 1 hour, that means when there's no request, the system will wait for 1 hour window before terminating the instance. If there is a request coming in this 1 hour, request will be served with the warmed instance immediately without cold start. So from user point of view, it just gets a very quick cold start. Actually, it's warm start, not a cold start. But
Yeah.
actually, this mitigation have two problems. First, that customer have to pay for this 1 hour idle time. Actually, this is a violation of the user requirement and expectation for service.
Right.
And the second issue is that if there's no request coming in this window and the instance is terminated, next request will trigger the cold start, and the user will suffer from the cold start latency,
Right.
and it's very bad user experience.
Right. So that is the reason they just keep it provisioned so they can avoid the cold start, basically.
Yes.
And with that, this also leads to basically the GPU utilization as well, right? So the GPU is just sitting idle, and the most of it is just being wasted. Right? Is that also a problem as well, right?
Yes, yeah, because we cannot scale down to 0 when there's no request, and we have get the GPU application warm, and actually they occupy the GPU and they just cost the GPU price, and actually for this kind of large scale down window, somehow it's just like the always on service. It's not a true service.
Serverless.